100 centimeter cube of oxygen diffused in 4 seconds. Anything centimeter cube is the volume. So that will be the volume of oxygen gas. So volume of oxygen gas equal to 100 centimeter cube. So the time taken for this 100 centimeter cube to diffuse equal to 4 seconds. So the time taken for oxygen gas to diffuse equal to 4 seconds. So 50 centimeter cube of gas Y, that is another gas, diffuse in 3 seconds. So the volume of another gas, which is Y, equal to 50 seconds. So the time taken for this gas Y to diffuse is 3 seconds. So let's call it Ty equal to 3 seconds. Now calculate the relative molecular mass of gas Y. So we are looking for the mass of gas Y, so which is unknown. So according to Grant's law of division, R1 over R2 equal to the square root of molar mass of gas 2 divided by the square root of molar mass of gas 1. So that is when your question is talking about a gas diffused. So you use R1 over R2 equal to the square root of the molar mass of gas 2 divided by the square root of the molar mass of gas 1. Then when we look at parameters given here, there is nothing like R. R is the rate of diffusion of gas. So there is nothing like rate of diffusion of gas from the parameters given. So therefore we have to look for rate R1 equal to volume divided by the time taken. So to calculate rate now, rate equal to volume divided by the time taken. So we are looking for the rate of what? Rate of diffusion of gas, of the first gas, of oxygen gas, which is R1. So that will be equal to, the volume of oxygen is 100. That is 100 divided by, the time taken for this 100 to diffuse is 4 seconds divided by 4. Then we look for R2, that is gas 2. The second gas mentioned from the question is gas Y. So the volume of gas Y, that is volume divided by T. So volume of gas Y equal to 50, then divided by the time taken for this 50 to diffuse equal to 3 seconds. So therefore we can calculate rate. So that would be R1 divided by R2 equal to the molar mass of gas 2. M2 is the molar mass of the second gas. This is the first gas. This is the second gas. So the first gas is oxygen. The second gas is Y, which is unknown. So the molar mass of the second gas divided by the molar mass of the first gas. So we have to look for the molar mass of oxygen gas. So oxygen gas is O2. Then the atomic mass of oxygen equal to 16. So they've given us, which is equal to 16. Then we have 2 atoms of oxygen. So that would be times 2 equal to 32. Now R1 now, our R1 is 100 over 4. 100 divided by 4. Then divided by R2 is 50 divided by 3. 50 divided by 3, which is equal to the square root of M2 divided by the square root of M1. That would be the molar mass of oxygen, the first gas. So M1 equal to 32. The mass of oxygen gas. So divided by 32. 100 divided by 4. Then division will change to multiplication. So the fraction will turn upside down. That will be 3 divided by 50. 50 cancel, 50 here 2. 2 here 1, 2 in 4 is 2. So which is equal to the square root of, so we can bring everything inside the square root. That would be the square root of M2 over 32. So we are left with 3 divided by 2 at this side. 3 over 2 equal to the square root of M2 divided by 32. So we have to look for a way to eliminate this square root. We have to eliminate the square root. So we square both sides. We square this side, then we square this side. So these two we cancel this square root. cancel square roots. So 3 raised to power 2 will give us 9. 2 raised to power 2 will give us 4, which is equal to M2 divided by 32. So we cross multiply to get the value of N2, which is the molar mass of what? Of gas Y. So this one will give us N2 equal to 9 times 32, then divided by 4. So 9 times 32 divided by 4 will give us 72. So 72 is the relative molecular mass of gas Y. So this is the relative molecular mass of gas Y.